All right, here we go. The rest of 17. So we're doing 17.2 and 17.3 together. And we're going to start graphing linear equations. So remember, linear meaning straight line. So I can graph linear equations. I don't know what a question is. Here we go, equations. So key terms is this first one is y equals mx plus b. Okay, so this is actually very similar to the form we've been using, right? We've been using y equals kx. Well, now we're just changing k to become m, and b, we've always actually had b, but in our form it was always 0, because that's going to be, first term, our y-intercept. So the y-coordinate of a plane where a graph crosses the y-axis. So y-intercept because it crosses the y-axis, and it's 0b. And when we had proportional relationships, they were 0, 0. So very, very similar. So then we've got the slope. Slope's m, right? That's our constant. That's not changing. And it's where we're going to do y1 or y2, whatever one you want to do. Take away y1 over x2, take away x1. And remember how we talked about it doesn't really matter if it's 1 and then 2, right? So slope-intercept form is a linear equation written in the form y equals mx plus b, where m is the slope. So that's still been our k, we've been doing this, and b is the y-intercept of the equation's graph. So that b has been 0, 0. Now, if you remember from 17.1, it's going to be some other number besides just 0. So this is our first practice. We're going to determine the rate of change and find the initial value. And the initial value is also our starting point, or our y-intercept. So this is a phone salesperson is paid a minimum weekly salary and a commission for each phone sold, as shown in the table. Confirm that the relationship is linear and give the constant rate of change, or m, in the initial value b. So we're going to first confirm that the rate of change is constant, and so that what we're going to do is find the slope between these. Okay, so let's just, right, when we change of income y, change of phone sales x, it's just that subtraction. Remember, we're going to subtract these. So these all go by 10, right? If I subtract, it's 10, and I subtract, it's 10, and I subtract, it's 10, right? So we at least know that the change in the phone sales is for sure 10. Okay, so then we're going to subtract here. And so we subtract, and we would have to, I do this in my head really quick. So what is that, 150? Right, and this one's 150, and this one's 150. So what we notice is they all come out to 150 for our y change. So that shows that it's constant. And then we're going to reduce this, and we're going to get 15, right? Because I'm going to divide by 10 and get 15. So that's our slope, m equals 15. And what that means is that it's $15 number of phones sold per phone sold. Remember, that's our unit rate. So m equal 15 means that it's $15 for every phone sold. Okay, so now what we're going to do is we're going to find the initial value when the number of phones sold is 0. Okay, so there's two ways we can do this. One way is just move down the table, right? Subtract until we get down there. The other way we can do it is take this information we know, right, sloping 15, and figure it out what it is mathematically. And that's the way I want to do it, is actually do it mathematically in case we don't have a table. So we want our initial value where it's 0 phones sold. So that's our x, right? X is the number of phones sold. And we need to figure out what it is for y. What would it be if I didn't sell? What would I get if I didn't sell any phones whatsoever? So what we're going to do is take information we know. So I'm going to use this point 10 and 480. And I'm actually going to plug it into this equation, right? This is x, and this is y. So I'm going to go 480 equals my slope, 15, and I'm going to times it by 10, and I'm going to put b because I don't know what b is yet. We don't know our initial value. We don't know what it is when I don't sell any. So what we're going to get is 480 equals 150 plus b because we didn't do anything with that. Now you have to think back to last year when we solve equations. This is just a one-step equation, right? This is a positive or addition, and so the inverse, when we're talking about that, inverses would be then to subtract. So we're going to subtract, we get 0. I'm going to come over here, 0. 8 take away 5 is 3, and 4 take away 1 is 3, and that's going to get us b. So b is 330. So what that means, the initial value is 330. The salesperson receives a salary of $330 each week before they sell any phones. That's what that means. So if you sell 0 phones in a week, you will make $330 no matter what. Okay, so that's how that works. So now that we have M and we have B, remember this is B, wrote it up here, we can write the equation. Y equals 15x. See how that looks very similar to when we did proportions? The only difference is we're going to do plus 330. That's the only difference. Okay, so just pretend that's not there. Look, it looks exactly like a proportional relationship. And so then we're going to add the y-intercept because it's non-proportional. It has a different starting point than 0, 0. Okay, so we're going to do the same thing here. Find the slope and the y-intercept of the line represented by each table. So what I would do is maybe even pause and see if you can find the slope and check if you found it correctly. Then pause, find the initial value, and then check. Okay, that's what I would suggest. So go ahead and pause here, find the slope, and then unpause to see if yours matches mine. Okay, so you either can subtract, 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 right? So that gets me 2, 2, and 2. And then I can subtract, 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 and get 10, 10, 10. You really could have picked 2 points, right? 8, oops, not y's over x's, I mean y over x, so 52, take away 32, right? That's this one and this one. And then like 8, take away 4, you could have done it this way too and gotten 20 over 4. But doesn't really matter, reduces to, sorry, phone just rang. Whoop, okay. 10 over 2, we'll notice that's what we got here, 10 over 2, which just gets us 5. So our slope's 5. So now to find the initial value, I'm going to take just one of my points. So I'm going to use 222. And if you want, this is a good place to pause again and check to see if you can find the initial value yourself. So I'm going to use this point, x and y, and I'm going to plug it into the equation y equals mx plus b. And so y is 22, m is 5, x is 2, and we don't know b. So we put it back in. So 22 equals 10 plus b. Remember, one-step equation, inverse operations, take away 10, and we get 12 equals b. Okay, and we can check to see if that fits our pattern, right? If I went back 2 and back 10, I would get 12, right? And this would become 0. So it does fit our pattern from our table. So then we write the full equation, y equals 5x plus 12. All right. So now what we're going to do is take that same equation and we're going to graph. So just like with proportional relationships, we can make a table. That's definitely one way we can do it, but there's actually another way we can do it. So remember this number is B and this on slope. So this tells us where it's going to start. And so it's going to start at 0, -1. That's my y-intercept. And remember M being 2/3 is going to be our rise and then our run. So remember those triangles I kept talking about when we first started with slope? This is going to come into play. It's going to be our triangles. So let's first start with our y-intercept. The reason I made it -1 is because it was subtract, right? If I add the opposite, it becomes negative. So there's where that negative came from. So I'm going to go down here, right here. I'm going to put a dot, 0, 1. So now from there, I'm going to use my slope, my rise and my run. And I'm actually going to do that. I'm going to count 1, 2, and 1, 2, 3. And I went up because it's +2, and I went to the right because it's +3. So then I'm going to go up 1, 2, 1, 2, 3. Look, there's my triangle. I'm going to do it in a different color. 1, 2, 1, 2, 3. Positive, positive. So that's all I've done is made my triangle. Now, I'm going to also use this triangle. -2 over -3. That changed nothing. Is -2 over -3 still just +2 over 3? Yes, I changed really nothing. But what it allows me to do is to now go down 2 and 1, 2, 3. Down 2. 1, 2, 1, 2, 3. So same triangle, except the other direction. And then once I have enough points, I can connect them and make my line. So we're taking everything we've done before, right? We found the slope off the graph. Now we're using that slope to make the graph. Okay, so this is why it was so important to understand that you could do triangles up and over or down and over, that they're the same thing. Okay. So things to remember, right? That M is our constant, that it's our y's over our x's, and that B is our y-intercept. That's short for intercept. It also is your initial value. I think I totally spelled that wrong. And it's where the graph starts. Oh, we can also add here, this is our triangle. All right, our triangle. Rise over run. All right, so independent practice, this is where you're going to practice finding the slope and the y-intercept on your own, and then practice finding the graph on your own. Okay, so just remember to use, for this first one, your subtraction, y2 minus y1, and then x2 minus x1. And then on the graphing, don't forget this is your starting point, and this is our triangle. Starting point, triangle. All right, see you next time.